In this question, we know that joint density the joint probability density function of xy equals to this, and when x to the power of 2 plus y to the power of 2 smaller or equals to 1, the probability density function is equals to b, and otherwise equals to 0. And in the A question, we want to find b so that the above defined function is a valid joint PDF. So the b needs to satisfy that. Equals to 1. And this part obvious equals to b multiple double integral dxy dx dy. And it is obvious that this part is equals to the area of the circle, and the area is pi, and so it is obvious that b multiple pi equals to 1, so b equals to 1 divided by pi. So this is a question. In the B question, we want to find the expectation. First, we want to find the expectation of x, and using the definition, ex equals to integral from -1 to 1, x multiple the probability density function of x dx. And in order to calculate the expectation of x, we need to calculate the probability density function of x, and fxx. This is the marginal probability density function, so we can draw a line. We can draw a line, so we can find that the line is intersects with the circle of with 2 points, and the first point and the head is square root 1 minus x to the power of 2, and the second is negative square root 1 minus x to the power of 2. And so the marginal probability density function of x equals to the integral from negative square root 1 minus x to the power of 2 to square root 1 minus x to the power of 2, and 1 divided by pi and dy. And so we can obtain the probability density function of x, and it is equals to 2 multiple square root 1 minus x to the power of 2 divided by pi. And so we can calculate the expectation of x. And obviously we can find that the function x multiple 2 multiple square root 1 minus x to the power of 2 divided by pi. This function is an odd function with respect to x, and because the integral region is -1 to 1, so it is obvious that this part is equals to 0. And also we can use the same method to calculate the expectation of y. And using the definition, the expectation of y equals to -1 to 1 y multiple fy y dy. And the probability density function of y equals to this. And also we can draw a line, which is parallel to x. And we can also find that this line intersects with a circle with 2 points. The first is the height is negative. The point is -1 minus y to the power of 2, and the second point is square root 1 minus y to the power of 2. And so the fyy equals to the integral from -1 minus 1 minus y to the power power 2 to 1 minus y to the power of 2, 1 divided by pi dx. And so the result is 2 multiple 1 divided 1 minus y to the power of 2 divided by pi. And we can also we can write ey equals to integral from -1 to 1 y multiple 2 multiple square root 1 minus y to the power of 2 divided by pi dy. And we can also find that the y multiple 2 multiple square root 1 minus y to the power of 2. This part is an odd function with respect to y. So it's obvious that this part also equals to 0. So ey is also equals to 0. And then we want to calculate the expectation of when y is equals to little y, and the expectation when y is equals to little y and the expectation of x. And this using the definition, and we can find that when y is fixed, and we can draw a line, and this line is parallel to x-axis, and the line will intersect with the circle with 2 points. And the first point, and this point is negative square root 1 minus y to the power of 2, and this point is square root 1 minus y to the power of 2. And so we can write the expectation as this format. and x multiples the probability density function probability density function of under the condition y equals to y and the probability of x and dx. And this part we can use in the definition equals to f the joint density function of x and y divided by f marginal probability density function of y. And and because from the conclusion above we know that this part equals to 1 divided by pi divided to multiple 1 minus y to the power of 2 divided by pi, and so the result is 1 divided by 2 multiple square root 1 minus y to the power of 2. And so it is and so we can write the expectation as and we can also find that the function x divided by 1 divided by 2 multiple square root 1 minus y to the power of 2. This part is an odd function. It's an odd function with respect to x, and so it is obvious that this part the integral is equals to 0, and because the integral region is from negative square root 1 minus y to the power of 2 to square root 1 minus y to the power of 2, so x y this part equals to 0. And also we can write the expectation of ex y equals to 0 because for every y the expectation of this is equals to 0, so this part also equals to 0. And also we can calculate the expectation when x is fixed, and this is equals to, and we can also draw the circle and we can find that when x is fixed, and we can draw a line, and the line will intersect with the circle or intersect with the circle with 2 points. The first point, and the head is square root 1 minus x to the power of 2, and this point, the head is negative square root 1 minus x to the power of 2. And so the expectation can be read as y multiple f the conditional probability density function when x is fixed dy, and this part we can use in the definition to calculate, which is equals to fxy divided by fxx. And from the conclusion above, we can know this part is equals to 1 divided by 2 multiple square root 1 minus x to the power of 2. And so the expectation can be written as this. Y divided by 2 multiple square root 1 minus x to the power of 2 dy. And it is obvious that the function y divided by 2 multiple square root 1 minus x to the power of 2, this part is an odd function with respect to y. And so it is obvious that this part is, and because the integral is from negative square root 1 minus x to the power of 2 to square root 1 minus x to the power of 2, so it's obvious that the conditional expectation when x is fixed is equals to 0. And also because for every x this part is equals to 0, so we can know the y x capital X is also equals to 0. And so and last we need to calculate the expectation of capital X capital Y. And using the definition, the expectation equals to dxy xy fxy xy dx dy. And this part we can use we can find that it is equals to -1 to the double integral and we can also find that it is obvious that this integral is equals to 0, and so the expectation of x multiple y is 0. And so this is a B question. Then the C question, we want to prove or disprove x and y are uncorrelated, so we need to we can using the conclusion above, because the expectation of x multiple y is equals to 0, and x and equals to 0, y is also equals to 0, so exy minus x multiple ey equals to 0. So it's obvious that the xy are because the covariance is 0, so the xy are uncorrelated. So this is the second question.